So it's fantastic to see such a passionate community here in India. Everyone's so enthusiastic and energetic about working towards Kubernetes and helping us build an amazing community here and continue to build and grow around the world. But when we get started with Kubernetes, it can be quite overwhelming. It can be quite daunting. There's lots of new skills, there's lots of new ideas, new approaches. And this can become more challenging when we're getting started. And so here at Katacoda, we spend a lot of time trying to understand how we can help developers get started more effectively learning Kubernetes. And one of the things that we have found that helps is to have a goal, have a purpose about what you're driving towards, and have that as a focus. This ensures that you are remaining on target, and it also ensures that you don't miss key aspects and key parts of what you're trying to achieve, and miss the key goals. And with the announcement from Dan this morning about the discount on the exam, there's no better time to start setting your goal as becoming a certified Kubernetes application developer. And that's what I want to help you get started with and help you on your way today. So as Liz kindly introduced, my name is Ben Hall. I am a certified Kubernetes application developer. I went through the exam, I've got the experience, the war stories, and I can happily share those with you. But I'm also the founder of Katacoda. And for those who haven't seen it, Katacoda is a free interactive learning platform for software developers. We primarily help people understand the cloud-native technologies, how to get started with things like Kubernetes, Docker, Helm, and all of the other related technologies within this amazing ecosystem. Everything is provided via the browser. You get a live interactive environment available for free, running things like Docker and Kubernetes, alongside step-by-step instructions to help you solve goals and help you understand how to complete tasks. But what I want to talk about today is the exam. And so Dan kind of gave an indication this morning, but let's go into some more details about what the exam actually covers. So the certification is there to either ensure that you're an application developer or you're a Kubernetes administrator. The goal of the application developer exam is to certify that users can build, design, configure, and expose cloud-native applications for Kubernetes. It's a hands-on exam. You need to be confident and you need to be comfortable understanding how Kubernetes works and how to deploy your own applications and manage the Kubernetes infrastructure, because you will be given a live terminal with live clusters that you're expected to control and configure and meet the requirements of the question and purpose. And the exam covers 7 key topics to ensure that the person has a very strong understanding of everything required in order to deploy applications onto Kubernetes. And so it will cover things like the configuration. How do you architect your application to run reliably and scalably on top of the platform? How do you design to ensure that other parts of Kubernetes can discover and communicate with your application correctly? But also other aspects, like what happens when it goes wrong? Can you identify where the logs are? Can you identify how to get metrics from your system using Kubernetes? And this gives you a great foundation. And by working towards this set of criteria, you can be confident that you have a great understanding of what Kubernetes is. Make sure you haven't missed any key components, regardless of whether you take the exam in the end or not. But unfortunately, when you take the exam, you are under NDA. So as a speaker, talking about how you can pass the exam, it makes it somewhat difficult. I can't say the answers, and I can't give you the exact commands. Fortunately, what I can do is show you how to administrate Kubernetes and how to start deploying your applications and how to start working with Kubernetes on a daily basis, some of which may be covered in the exam itself. And so I'm going to flip over to Katacoda, and what we have here is our Kubernetes cluster. Because we're taking the application developer exam, we aren't concerned with how that Kubernetes cluster has been provisioned. That's covered by the administrator exam. All we care is that we have a Kubernetes cluster running. And so when you're practicing yourself, and when you're understanding and learning Kubernetes, this could be done with Katacoda, it could be done with Minikube on your local system, or one of the cloud providers and one of their managed Kubernetes service offerings. What's important is you understand how to look after and how to understand that Kubernetes cluster once it's been set up. And at the heart of this is kubectl. Kubectl is a command line tool that you'll be using to get to understand the cluster, the specifications, what's been deployed, and to make changes and deploy your own application. And so in here, we can ask kubectl what's the setup of our cluster. In this case, we have 2 nodes. We have one called master, so this is running all of the Kubernetes key components. And then we have a single node, which is running all of our workloads. And because we're going to be dealing with the Kubernetes kubectl command line so frequently, being able to optimize how that works for us is really important. And so a great tip is to use the auto-completion. So with this, we can pipe in kubectl completion bash, because we've got a bash command prompt, and we can pipe that into our current session. And what this gives us is auto-completion now when we're typing in commands. So we can do kubectl, and we can type in G, and then we hit tab, and it will auto-complete it for the rest. If you start typing in N to get nodes, what it will now do is gives us all of the resources that are in the Kubernetes cluster that begin with N. So now we have a great way to discover what the options are, what's available within our cluster, and also saving some typing at the same time, which is important when we're in an exam or maybe a stressful presentation situation. So we have this, and now we have our command line, and we've got some optimizations to make it a little bit easier to work with. So how do we start deploying our application? And as it's been indicated in some of our talks previously, we have resources. Resources define how we want the configuration in Kubernetes to behave and what we want Kubernetes to actually do for us. And for our application and how we want our application deployed, that's managed by the deployment resource. And using kubectl, we can create our new deployment. We can give it a nice friendly name so we can refer to it when we need to look at it later, called, in this case, example HTTP app. And then we can point it towards the Docker image. What image do we want our application? How does that get deployed? Where is that application built? In this case, an example HTTP server from Katacoda. And again, using kubectl, we can get all of the resources and all of the information about the resources in our cluster. So in this case, get deployments. Previously, we used get nodes, and this listed all of our nodes in the cluster. We're now saying get deployments, and this lists all of the applications, all of the deployments that have been made into this Kubernetes application. And we can see here that we've got our example app that we just deployed. It's saying that we've requested, got 1 instance available, and everything's available and happy. But under the covers, what's happening is that Kubernetes is launching a pod. And so if we call get pods, we can see that we've got this 1 pod running. It's been prefixed with the name of our deployment, in this case, example HTTP app. We can say that it's running, and we can get the status. If something went wrong, the application crashed, it couldn't find the Docker image because we had a typo, or it hadn't deployed yet, then that error would be listed here. If it had crashed, the restart count would increase. But in this case, you can see that everything is healthy and everything is happy. Now, a pod can be made up of multiple containers depending on the requirements of your application. And this allows you to have lots of greater control in terms of how your application is architected, and great when you're migrating from existing systems into a Kubernetes world, being able to structure your pods which match more closely to how your current systems are architected is a great advantage to what Kubernetes can bring. And we can see in this case we've got 1/1. That means that there's 1 container running and it is started successfully. If we had multiple containers, then that number would be reflective of this. We can find more information. So we can do get pods. We can do -O, which is outputting in a different format, and we can say wide. And this gives us more information about what that pod information has. So in this case, we can see what node that pod is actually running on. Great if we need to start debugging any problems that exist within our application, we can see where our workload is actually running. But we can find even more information by doing describe. And so we can start typing this. We need to give it the name of our pod. So if I type, so again, this is where having that auto-completion is great, because I can just type the start of EX, hit tab, and it will complete the rest of the name for me, and I don't have to figure it out. And in this case, it's described all of the internal configuration and all of the internal details. And so we can see when it got started, we can see the internal IP address, which Docker image is being used, and what version that would be, and all of the other events, what happened, and what what events occurred in order to start that pod. In this case, we allocated it to a node, it went off, it pulled down the container image, and then that container got started. And this is a great way when you're managing your pods and want to understand what's happening under the covers, you can use this described on any object within the Kubernetes cluster. But if we just started to randomly deploy all of our applications, in production, that's going to become very quickly very busy, very confusing, and very error-prone. And so it's much easier if we can start to structure our applications in a manageable way. And Kubernetes solves this using namespaces. So a namespace is a way that we can organize where our components are being deployed into. And by default, in a Kubernetes cluster, we have 3 namespaces. We have default, which is where, if we haven't specified anything, our deployment will run and be launched into. And then we have 2 internal Kubernetes, kubepublic and kubesystem, where all of the Kubernetes components are running. And if we wanted to see what was running in that namespace, we could go get pods, -n, and that will output the name, that will output all of the pods within that namespace. And so now we can see much more information than what we did previously, because we now see all of the internal Kubernetes components, such as core DNS, XCD, the scheduler, and the metric server. And also, there's shorthands. So if we want to save on a type in again, we can just use NS. Why type namespaces where we can just do NS and get exactly the same result? So if we continue, we can now start using this to structure our applications too. So just like how we created a deployment, we can create a new namespace by doing kubectl create ns or namespace and give it the name. In this case, test ns. So we now have a new place where we can deploy our applications. And so we can say deployment create, give it a new name, give it the new namespace where we want to deploy into, and now that project is managing and working within its own namespace context. This can have its own security properties, its own security settings. It can be isolated from other things within a cluster, depending on what your requirements are. And again, now when we want to see what's running, we can say get pods, but just get me the pods that are in that one namespace. And it will filter out the results and just show you what's important and what's essential in these results. Now, as we move forward, we need to think about how we can scale. We've deployed our application successfully, but how can we scale that to meet our requirements? And again, one example of how this can be done is through kubectl with a scale property. So now instead of saying get or create, we're saying scale. Bring up more of the same instance. In this case, we're saying scale our deployment, give it the name that we're interested in this case our example app, and telling it how many replicas we want. How many instances of that pod do we want to be created? And so in this case we said we need 5 instances. And we can check using the command line again, what does Kubernetes know? You can see we've got that desired state of 5 instances and they've all been available. And when we list up pods, we've got our existing one, which was started 6 minutes ago, and our 4 new instances that have been created to help us scale with our load, help us manage those peak capacity demands. And if we set our replicas back down to 1, then Kubernetes will remove those unrequired pods and ensure that we have that 1 pod remaining running. But as was mentioned in the talk before, if we just use kubectl constantly, we are error prone. We are liable to enter a mistake. Maybe we meant to scale up to 50, but accidentally we hit scale to 0, and now our application shuts down. This is not what we want to happen. And so we can actually look and we can manage the Kubernetes manifest, and we can manage that YAML definition directly from the command line by asking kubectl to edit a resource and edit our deployment. And so now we get that underlying YAML manifest that's been talked about previously. And so now we can come in, we can say, let's say we scroll down, we can hit and increase our replications, and let's say 7. Now you'll notice that I'm in Vim. Remember that in the exam, you're just going to have a terminal. So it's important that you're comfortable with using Vim or Nano or some terminal-based editor so that you can make these kind of changes if you need to. Likewise, when you're working within a production environment. And so if we exit, we hit escape, and to save, we can type W and then Q, and we can see that appear at the bottom. And that will save the configuration, save our changes, and quit Vim. Kubernetes will detect that that's been happened, they will detect that change has been made, and it will automatically apply those changes to our cluster. And in this case, we should see that we should have 2 additional replicas being started, which they have done now. So as we moved forward, we've now got an application which is capable of scaling. We've got enough replicas to match our load and match our requirements. And if we have multiple nodes within our cluster, Kubernetes has automatically scheduled those as spread as possible to ensure that if we lose a node, then we don't lose all of our application capabilities and capacity at the same time. So how do we manage updates? So there's 2 approaches that we could do with managing updates. We could change the YAML and potentially use something like GitOps to have that YAML definition stored in source control, and then use something like Flux or Jenkins to manage that pipeline and roll it out to production. The other way, which will be comfortable in using kubectl, is by setting the image for our deployment from the command line. And in this case, we're saying we want version 2 of our Docker image. And we can use the command line to actually see that rollout occurring. Kubernetes will manage that in a safe way. It will ensure that there's enough capacity available based on the number of replicas so that we never lose any downtime. It will roll out the new images and pause to make sure that they are starting correctly, and then continue to roll out the next. So it's doing it in a phased strategy. And then at the end, it will terminate all of the old instances because they are no longer required. And we can see that with the rollout command. But mistakes do happen. Like every now and again, we deploy an image and it has a critical bug. Fortunately, again, Kubernetes is there to manage us and help us become unstuck from a sticky situation. And so in this case, we can use kubectl rollout. We can say undo our deployment and tell it what application to undo. Kubernetes keeps a state of what change has been happening and what has been rolled out and what versions are there. And so now Kubernetes will detect that we've requested a rollout, and it will automatically revert what change has been made in the last deployment, in this case, updating to version 2. And then it will roll back all of our changes and go back to that previous version. If we go back and say get pods, we can see that all of our applications got started, and now they've been shut down, and we have everything left and now running back in our safe, very happy version 1, and we're now back into a reliable, safe cluster. So we've got our application deployed, we've got everything being scaled up and scaled down. We can do managed rollouts and rollbacks if required. So how do we make this available to external parties and other people? Now this is managed through services. A service is a way that we can define how do we want our applications to be available and utilized by other applications within the cluster, or maybe externally from a load balancer or a router external to the cluster. And so using kubectl, it can manage the creation of that service for us. And so we can tell it to expose our deployment. And we just need to tell it what port our application is running on. In this case, it's port 80, but it could be 3000 if you're running a Node application, or 5000, for example, by default if it's an ASP.NET application. And this will go through and it will create our service. And we can do get service, and can see all of the services that we've been provided. And we have that cluster IP address, that way that we have a consistent IP that we can send traffic to, and that will be routed through the Kubernetes cluster to an available pod, which will then manage our request and return us with our results. And again, if we wanted some more information, we could describe that resource. We could describe what was happening and what does Kubernetes know. And so we can see that a resource service is available. It's got the IP address. And then we have the endpoints. All of the endpoints, all of the pods that Kubernetes will be sending traffic towards that's coming in on this service object, this service resource. And so we can make sure that Kubernetes has correctly detected everything and correctly linked up our service to our deployment. But how does Kubernetes know? How does Kubernetes know that we have a deployment and that's where we want all of our traffic going to? And this is managed through labels. Within Kubernetes, every object has the ability that it has labels attached to it. And we could see that within our service. We can see that it's got a label called app equals example HTTP server. So that's given us some context. So now ourselves, using kubectl, can query and say, give me everything which has got this label, or other components within Kubernetes can use it to discover and automatically configure itself based on these label selectors. And as we can see nearer down in the middle, we have this selector property, and it says select everything which has got the label app equals example HTTP app. And this is what was automatically allocated when we created that deployment object by Kubernetes. But this is completely customizable. You have complete control of any name value and key value pairs that you wish in order to identify how you want your traffic and your objects to be discoverable and structured. And so using our get command again, we can filter and we can say get all of these services that just have this label. And then we can actually start inspecting the object. Within the kubectl, we have Go templates and Go template syntax. And so we can actually start picking out key properties from the information being returned. And so instead of listing everything possible, we can just get the bits of the information that we need. For in this case, what is the cluster IP address? And then we can start piping this and combining this with other commands, for example, curl. So go off, find my service which has got the label, find my cluster IP address attached to that, and then pipe that into curl. And then at the end, we have our beautiful HTTP response telling us, in this case, what example pod processed that request. And if we send another request, you'll see that Kubernetes is managing the load balancing. We'll get a different response each time because we're using this service concept. And the service got multiple endpoints, and so it's spreading the traffic across to ensure that we have as much reliability and performance as possible. So as we continue our journey of managing applications, the next thing we need to do is how do we manage it when applications potentially go wrong? What happens when errors occur? We need to know how to debug and how to identify where problems exist. And this again can be all managed via the kubectl using logs. We can ask for the logs of any pod within our system. So using a very similar property to how we queried for our services to get the cluster IP, we're now querying and saying, get me the name of one of our pods, and then piping that into kubectl. In this case, we've got an amazing application. It's all happy working, it's providing some nice, helpful messages to say that it's indicating and it's listening correctly, but you could imagine that if something went wrong, something happened within the cluster, then this would appear with all of our errors and all of the information that we could help to identify where the problems occurred. And there's more metrics within the cluster that we have access. So we can say, tell me all of the events that are happening within our cluster by saying get events, if I can type kubectl properly. See, didn't have auto-completion on that one. So now I can type get events, and this tells us the state of everything that's happening in our cluster. So if we're aware that problems are occurring, saying get events will tell us, has there been any scaling events occurring? Have new objects been created? What information is happening to help us identify where problems may have occurred and where problems may have started? It also gives us more information about metrics. So we can find out information about the resources being used. So we can say kubectl, get me the top. So top aligning with Linux and Linux top and H top, get me the top nodes. And this will give you all of the stats about the processes and the resources that have been allocated to each node within our cluster. In this case, everything's lightweight. We've only got a small amount of CPU being used. But if problems started to occur, we could imagine that that CPU would spike to 100%. And it's useful to know which node is actually causing that problem. And then we could use CTL top pod, and that will actually give us more information at our pod level. So we could identify, is it one particular pod that is causing the problems? And then we could find the name, and then we could go off and we could use kubectl logs in order to see the logs and identify which problems may be occurring, or delete it and get Kubernetes to recreate it automatically for us. And so these are some of the core commands that you'll be using when you're dealing with Kubernetes on a daily basis. You'll need to be able to understand how to deploy applications, how to create deployment objects and resources, how to manage pods and understand what pods are existing, what namespaces exist, scaling applications, your day-to-day deployment, day-to-day operations of being an application developer on top of Kubernetes. But it wouldn't be an exam, and it wouldn't be exam prep if there wasn't some homework for you to complete. If I don't. And so there's some great homework. Firstly, you need to register for the exam. You've got those 6 weeks that Dan mentioned. You'll get that email on Tuesday with a discount code. So make sure that you register and claim that spot in order to have some goal, something to work towards. It doesn't have to be this month, doesn't have to be this week. You could book it for 6 months' time, but at least you have something to aim for and something to work towards, plus you take advantage of that discount at the same time. There's free training available, so the Linux Foundation does amazing courses on Introduction to Kubernetes, so a great way to understand these principles, these foundation materials, in order to know how to work with Kubernetes on a daily basis. We have amazing meetups all around the world, and one particularly here in the local city, where you can go and you can learn from experts, you can learn from other peers, you can share ideas, share knowledge, learn and be inspired by what's happening. And if you have any problems with your exam prep, then you can just go and ask them directly, and maybe they'll give you some helpful tips, hints and suggestions in your warm-up to taking that exam prep. And there's Katacoda from ourselves. So we have lots of Kubernetes content that's available that you can take to learn the foundations, learn how you can start working with Kubernetes, or directly in your browser, all available for free. And we have everything I showed you today. So if you want to refresh, if you want to go back and try the demo that I just showed you today, just go to katacoda.com/KCKAD prep, and you'll be able to take that demo that I showed you, experience the command, see how it all works in reality. And with that, I'd like to thank you very much. I look forward to hearing about your stories, experiencing about your successes with the exam, and your continued success with Kubernetes community as a result. Thank you very much.